I'm Grace, and now I will be demonstrating our project in real time. I will be going over how we set up our virtual machines, executing the attack using Wireshark, our Visual Studio Code program, and our successful output where our AI is able to detect cyber attacks in real time. Now, let's start our project demonstration. We have set up two virtual machines, one attacker and one receiver. Let's go to our attacker's virtual machine. So in our attacker's virtual machine, we will be running a cyber attack called SynFlood. We can do this by using a program called NetWag. NetWag is a tool that allows us to run cyber attacks. So in our case, we want to run a SynFlood attack. So I will be searching up SynFlood. And here I will be inputting the IP address of our receiver's virtual machine, which is 172.168.128. Then I will keep the port as 80 as we wish to communicate through HTTP. Then we run the attack. Now our SynFlood attack is running and actively sending unsafe data packets to our receiver's virtual machine in real time. Let's go to our receiver's virtual machine. In our receiver's virtual machine, we will use Wireshark to see the received unsafe data packets from the attack in real time. We will be detecting data packets under the ENS33 network interface. And since we are only sending TCP packets, we can filter here that we only want to see TCP packets. And as you can see, these are all the unsafe TCP packets that is coming in real time from the SynFlood attack that we have just ran. Great! Now let's move on to our Visual Studio Code program. In our Visual Studio Code program, we have organized our work into two folders. The model folder, where it holds our trained decision tree classifier model here. This file is our trained decision tree classifier model, where after training in Google Colab, we imported it into Visual Studio Code. Meanwhile, the receiving folder contains receiving from wireshark.py and preprocessing features.py for managing network feature extraction, data packet preprocessing, and AI classification codes. So in our receiving from wireshark.py file, this file is responsible for extracting network features in real time. So if we scroll all the way down, you can see these three lines. This function streams in data packets from Wireshark into VS Code in real time. Then we pass in one data packet at a time through this function for further preprocessing. So if we scroll all the way back up, this is the defined packet callback function, where one packet will pass in this function at a time for processing, for feature extraction. So basically, we've defined several functions to extract features like duration, count, SRV sare rate, IP destination addresses and port numbers, etc. These are the defined functions, and as you can see, if we scroll down here, we've written and defined these functions to solely calculate the values for each of these features. These are the features that we're trying to extract from the network. Cool! Once we have extracted our desired feature from the network, we can pass these features into our next file, which is the preprocessing features.py file. We pass in the raw features one at a time, into this file, into this function. So let's go to our preprocessing features.py file. So this file basically pre-processes these raw extracted features from the network, the same way we pre-processed our dataset. This is done so that we can feed these features in a format that our AI recognizes. So yep, these are our pre-processing steps. And once we're done, we are ready to feed these features into our AI for real-time classification. So this is the line where our decision tree classifier is predicting the preprocessed features one at a time. And if we scroll all the way back up here, this function, so our AI predicts either 1, -1, or -2 based on the given features. Each number corresponds to a message, which is then printed. For instance, if the AI predicts -1, it means that there is a cyber attack detected, and users will be alerted. Finally, let's now run our program so you can see our successful output in real time. Yep, so currently you can see these print statements show the extracted network data in real time. So these are all the extracted network data. And yep, there you go. As you can see, after our program has successfully extracted the network features, pre-processed these features, our AI has successfully predicted that there is indeed a cyber attack happening currently. And this is true because we have just ran a SYN flood attack from the attacker's virtual machine to our receiver's virtual machine. There you go. It has successfully predicted that there is a cyber attack happening. Awesome. Thank you.